Hello and welcome to another build assembly video. So I'm going to show you how to build the Rucksack, which is an LCD driver board, and it uses through-hole assembly so that you can do this yourselves. Relatively simple. I've got a number of slides to take you through, and it's really simple. So let me just take you through some slides and give you an introduction. So what is the Rucksack? It's a very easy to use LCD display driver. Supports many commercially available LCD displays, and it's designed around the ATmega328P, and it runs our firmware, and that integrates using serial I2C, or however you want to call that, SPI, or with an optional Wi-Fi expansion board. You can use MQTT messages over Wi-Fi. So let me have a quick show you what it is. I've got it running in demo mode here. This is an LCD, and it's got two pieces of wires. I've just got it in test mode at the moment just to show you. So this is just running in test, and what's on the back of it is a board here, and that's plugged into the back of the LCD. I've got this here as a balance. I'll take that away. So this is the actual board itself, and we're going to build this board here. There we go. It's very, very simple to build. There is a process to it. We're going to connect it some power today, and then we're going to put it back into test mode. So what does it look like? It looks like a PCB. This is approximately, let me just measure that for you, 60 centimeters. 60 centimeters long, all through hole tech, so it's very, very simple to assemble. I've got a couple here, and it's essentially, once it's built, you can connect it up to your LCD, push that reset button on the back, and sure enough, that is fallen out. There you go. Press that reset button, and we're back in test mode, which is great, and we're going to be doing pretty well the same this morning. Okay, let me go back to the PowerPoint presentation, because we're going to whip through this. So what does it look like? An assembled board looks like this. There's a number of components on it, and the PCB is clearly annotated with its use. So in terms of, you can see on the board here, you can connect I2C here, serial. You can connect serial. Let me just draw some lines on here for you, which might help. The screen pointer. So here we've got I2C, which is great. Here we've got serial. Okay, you've got outputs here. You've got three outputs that you can control via a serial, I2C, or SPI, etc. And then you've got a serial. You've got an SPI connection up here, and you can select how that all works. A big reset button on the top, which I was pushing a moment ago. So it's really quite simple. You've got a communication select here, so we're going to select some different options in here, and those options will help me, help you choose whether you're using SPI, serial, or I2C. So let's press on with these slides. So you've got bill of materials. We can either supply the PCB as a full kit, so that's all the components, and the PCB and the firmware on a chip, or you can take the kit, you can take the PCB, you can take just the firmware. It's up to you what you want. But these are the components, and we provide a kit of parts. I got this from Stuart, and I've just took a photograph of it very quickly. And so what I've done, I create and for those who've seen my videos, I do this. It's very boring, but it's what I do. So I create a pick sheet, and I make sure that I've got all my components set up so that I can then not lose them. So I'll give you an example. If I go to the next sheet, just to prove I've actually done that. This may be upside down when I show you this, but I'll see how it comes out. There you go. Look, that is upside down because my camera is upside down. But I've laid out all the components on here so that I can find them all when I'm doing my build, okay? So when I'm doing my build, I don't have to struggle, okay? So here is the board, and that's at PowerPoint, and it does work quite well. It makes it much faster to actually pick the components out. I mean, in terms of the PCBs themselves, I put these two diagrams in because I think it's important that you can see the tops and bottom at the same time, so you can print that page out and use that yourselves. There is a full build diagram and document for this, and there's also a programming guide as well, so you can get all that from us off the website. So let me just go through the build process. I recommend you follow this process. It's in red. If it's in red, please review it carefully. If you don't follow the process, you are going to get components underneath other components, because this is a very small board. Okay, we wanted to have it very small so it could fit in the back of existing cases. All right, so let's get started. Well, all I'm going to do here is go through these slides, hold them up for 5 seconds. If I make a comment, I will, okay? But I'll just turn them through and you'll see the slides themselves. So just follow this, use the stop on YouTube to, or whatever you're using on the video to build, okay? So I'm gonna click away and then stay quiet. So when you put the caps on, please do not put any connectors on the bottom of the board. Again, no connectors, just fit the resistors. Flip the board over, and then again, do not fit any connectors or the socket or the 10K pot. Fit the top left, which is cap, etc., and the other components underneath the chip assembly. Then fit the vertical components on the top of the board by soldering in the bottom. Then flip the board over and fit the verticals on the bottom. Now, at this point, you may need to decide whether you're going to use the 16 one-way or the 8x two-way, depending on what configuration of LCD you've got. Plus, you might need to choose a socket or pins. This shows pins. I will be fitting a socket today. This also shows the layout of the chip select of SPI, I2C, and serial. Please note it's on the bottom right-hand side of the bottom of the PCB. Finally, on the bottom, fit the horizontal connectors, the 3 horizontal connectors. And then finally fit the socket. You can put the chip directly in. I'm not going to be doing that. I'm going to be putting in a socket and a 10K pot. Once that's all done, you can then fit your chip in, and you can provide 0 and 5 volts to the place where I've shown on the bottom right hand side. If you then fit a jumper, connect up your LCD, and you will see the same display that we saw on the video. It should be working. So let me go do that and we'll see how we get on. Well, welcome back to this is part 2 of the LCD driver board through-hole assembly, and I built my board. I've gone through the first section, and let me just recap what we're doing here. We are building a Rucksack, which is an LCD display that supports serial communication via USR serial, I2C, or SPI, or you can use a Wi-Fi board. What does it look like? It looks like this. But what I've done is I've gone through the process and I've assembled it. Okay, so let me just go to, took about 40 minutes with the pick sheets that I have shown in part 1. So this is the assembly of the bottom. I put in here the oscillator, the caps and the resistors, and then I move through to build the top. I then put in all the top components. Notice there were no sockets or connectors. Okay, really important. Then I put the vertical sockets in. Okay, then they stand vertically towards us. I flipped onto its back and fit the socket in for the LCD, and you can, let me think, you could choose to put pins in here. I chose a socket for my use case, and I fitted the horizontal sockets connectors on the back of the PCB. Flipped it back over and finally fitted the 28-way socket and the pot. Put the pot in the mid position so that when I actually powered it all up, it looked like this. Okay, so I'm now going to go out to the lab. This is a new one. This is truly a new one. I have built this. Here is the old one. Now the old one was yellow. Oh, sorry, the old one had yellow sockets on it, etc. This one does not. I built this morning, as I said, about 40 minutes. Let me bring another light in here to bring some light on the subject here. There we go. So I built that this morning. I've connected in 5 volts here and ground here, and that's marked up as the same on these two here. Okay, and I fitted the chip in, and I literally just put that on there, put it down, just knock the ground off, put the ground back on, and it's powered up. Now that light is now causing a bit of an issue, so if I just flip that light off, you can now see it. Now if I take the test off of that, if I take the test off of this, press the, if I, that's a bit loose. Right. I've taken the test off. You now get the, you're now getting the operational system. So this is now telling us, if I press the reset once more so you can see the whole process. Right, that's us. It tells you that it's fitted on a 4x20 and that's configurable. We can, so the dimensions are all configurable. 4 lines long, version 11 of the software. These are the defined characters, 33 defined. This is the, it's set on the PNW for the backlight is set to hex 80, that's midway. This is all the version stuff along the bottom here, and it says here that this is connected for 9.6 serial. Okay, there's a 3-second delay before it runs, and then this is the chip that's actually fitted to it, and it's running at. So if we want to upgrade the chip later on, we can. There we go. It's serially licensed. Okay, there we go, and we are operational. I can now go and hook that up to the I2C or the serial or SPI, and I will be talking to that. And I'm not going to show that now, but this is all done from this connector here on the back. Okay, there is a small connector on the back here. I'll turn the light back on so you can see it. There is a small connector here that allows you to configure it, and that is it. That's the build process. So I wanted to show you one of these being built, and I have built one of those this morning. Okay, 40 minutes it took, and it cost next to nothing, and it's fully functional. So let's go back to PowerPoint, finish off. So as I said, I fitted the chip, I provided the voltage, and I fitted the jumper and tested it, and it will come up with that test. It's working. So now it's down to you to go and integrate that with serial, I2C or SPI, and that's about it really. Go and enjoy.